Okay, Josie and Aiden, we're doing the last four like solutions for means and standard deviation, and then we'll probably try to get to the review. A little bit of the review. So here we go. All right, did you guys get all the examples written down and all the formulas and everything from yesterday? So we just have to solve, right? Maybe so. Okay. We'll find out. All right, let's do our hypotheses up here. H naught, H1. Okay, and we are doing, T I'll put it over here. T equals, I'm going to say T or Z, because we've got to figure out which one it is. T or Z, I am recording, yes. Okay, all right, example, 20 students. The average ACT is 20.5 with a standard deviation of 3.2. Test the claim that the average is less than 22. So my average is in fact less than 22, but will it always be that way? Or is it significantly less than 22? That's what I've got to figure out. What variable do we use for our hypotheses? Mu. Mu, first one's equal to what?
22.
22. The other one is less than 22. Which one's the claim?
Bottom one.
The bottom one. Okay, I'm going to fill out my bell curve, and this we only do critical value style, right? Well, yeah, but we don't do p-value method is what I'm saying. We have to do, which tail? Left. Okay, and what percent do we put in there?
5.
Yeah, I said for all of them, we put at the top, use fish value of 5% for all of them. So I'm going to put all 5% in there, which means like my middle
90.
would be 90% because we've got like that imaginary 5%, right? So non-significant would be 90%. 5%, the bottom 5% is significant, whatever, right? Okay. All right. We need to decide which chart do we use to look up our critical value number.
What's our P? 20 to use a T chart.
Samples 20s, N is 20, so we look up on the T chart. Okay. We need to look up 19 degrees of freedom. 19 degrees of freedom at 90%. 1.729, so it'll be negative 1.729. This is an imaginary, like positive 1.729. Right? Okay. All right, now what do we do?
We gotta find, plug it into the.
We got to find all our calculations and stuff, right? Okay, I'm going to go down here. N equals 20 is what we said. What is 20.5?
X.
That's X bar. That's the average of those 20, right? 20.5 is the average of that with a standard deviation of 3.2. So that's like S or whatever standard deviation they give me. And then this 22 is like what we're testing, right? The mu. Okay. All right. So I'm using this formula right here. I'm going to put him up here in this corner though. Okay. So T, what was the T again?
20.5 minus 22.
Yeah. No, not that formula. We're using this formula. I'm in the wrong spot. X bar minus mu. So 20.5 minus 22. Which is going to give us a negative number, right? Over 3.2 divided by the square root of 20. Okay, I would, if I were you, practice plugging that in and see if you get a number. I don't know.
What? What'd you say, Ellie?
I don't know. I got negative 2.096, which would be 2.10. Is that true? Somebody get that? Yeah? Matthew got that? Awesome. Okay. That's what I get for a number. This is my critical value. Okay, that's my critical value, negative 2.10. Okay. All right. Now what do I do with that info?
Wait, what'd you get?
Negative 2.10. That's my critical value. Because we're doing critical value method. Now we have to figure out where does he live? He lives like over here. I don't know if you can see that very well. He lives right there. Like in the darkened region. Okay, so does that mean we're equal to 22 or we're less than 22?
Or less than.
We're less than 22. We're in less than land, and we cross off the top. So our conclusion is
Reject.
reject H naught. Claim is
True.
elbow.
Claim is true. It is in fact less than 22.
No, it doesn't.
20.5 is significantly less than 22. Right? Okay, good? No? You didn't get negative 2.10? No? No? No?
That stupid divide when we just leave it on the top.
Okay.
I did. It just, then you get an error if you put it on the.
So I would, so this guy, what you got right there, enter, I would do divided by, under parentheses, what was he? 3.2.
I just had an out of line.
I would do that all at one shot, like that.
There's an option.
There you go.
There's an
Yep,
option.
yep, you're close. Okay, all right. So next we've got to do confidence interval method. So we've got to find the error, right? Error equals T or Z. Which one is it this time?
Same thing.
Same thing. T again, right? 1.729 is the T that I use from this chart right here, right? Okay. Times S, which is, I don't know what, 3.2. Yep. I've only had that number like a bunch of times. Divided by the square root of 20. So the error is, I don't know what that is.
0.0276.
0.0276.
No, sorry. 0.276.
0.276.
Yeah.
Okay. That's fine. 0.276 for an error. Okay, now what do we do with that error?
Plus and subtract that from.
Add and subtract from X bar, right? Okay, X bar was 20.5. So mu is going to live between, I take 20.5 plus and minus 0.276. So the top number is 20.776, right? The bottom number, I don't know, 20.224. I don't know, is that right?
Yep.
Yeah? Yeah?
I don't know. I'm just saying.
I'm sure. Okay, now, so this is the range that I've got, right? Does that mean we are equal to 22 or we are less than 22? This range is entirely less than 22. So, same results. I get that again. Reject H not, claim true, right? Just in a different way. Got it? Are you having problems again?
Don't tell me you're getting married to it. Got it.
What?
The self-payment.
Got it? Oh, is that a thing? Yeah, it's been a hot minute. Got it? Got it?
What was it called?
Soft parenting.
Yeah.
Soft parenting.
Or gender
Gosh, what was that? I'm trying to think back to what that even was.
It was like
Got it?
a-
Oh yeah, the girl that like
Red decisions and
red decisions and green decisions, and she's soft parenting like her uncle that's like very rude at Thanksgiving or whatever. Yeah, got it. Oh, I gotta watch some of them. All right, maybe since we were talking about it, my phone will send me those videos now. Got it. Okay, we'll see if it comes up. Next time I'm on my phone. Okay, now standard deviation. Only the chi-squared chart. Let's do our bell curve first. Actually, let's do our hypotheses first. H naught, H1. What variable do we use? Sigma. Equal to, and then whatever else, right? All the information is the same from up above here, so we use this same info, except now we're doing a standard deviation we want to say is greater than 3. So greater than 3 or equal to 3, and the claim is the bottom. Okay? Good? All right. Left tail, right tail, two tail, what we got? Right. Okay, and all 5% is going to go there, which means we have an imaginary 5% here, which means we have 90% in the middle, and we're going to look up on the chi-squared chart the 90% at how many degrees of freedom?
21?
19.
19? Is the number 21?
I think it's 20, and it's 20, just like before. So 19 degrees of freedom at 90%. You can give me both numbers off that chart because we'll need them later.
10.117.
10.117 and
30.144.
30.144. Thanks, Reese. Okay, there they are. So we don't really care about the 10.117, but we're gonna need it for the next box, so we might as well write it down. Okay, now we've gotta use this formula to plug all the junk in. So chi-squared is equal to n minus 1, which is 20 minus 1. If you wanna do that in your head, you sure can, 19. And what is S?
Standard deviation
Yeah, like which one is which?
of 3? Or
Arms.
the,
The bottom one is 3, right? Because that's what sigma is, right? And the top one is 3.2 squared. Yep. Okay, and then we get a number. $19 times
What?
3.2 squared divided by 3 squared. 21.69? 62. 21.62?
yeah. So you problem above.
It's the standard deviation from the problem above. We're using all the same information from the problem above, except now we're testing standard deviation. That's what this arrow means, by the way.
Oh, yeah.
Okay? Okay, now, where does that live?
In the middle.
In the middle.
And I get one of those?
Something there, right? Now, does that mean we are equal to 3 or we are greater than 3?
Equal to.
Equal to, right? Equal to land lives in the middle. Greater than land would be if we were in the darkened region, right? Okay? Make sense? Okay, I think when we get confused a little bit on like which to circle, which to cross off, you're comparing 21 to this 3. Just look at the symbol. If you're in this land, you're equal to. If you're in this land, you're in greater than land. The 3 doesn't mean anything. The 3 has been converted to a like z-score of 21.62. You're not comparing you're not comparing this number with this guy. So don't think like they're equal to. Like, no, that's not what you're comparing. Wherever he lives on the bell curve is which scenario you do this. So we're doing what? Fail to reject. H not, claim false. Got it? Feeling good about that?
Now we have to do the,
Yep. We got to do the other one. Okay, so here we do not calculate error, correct? Okay, we only do the chi-squared right, chi-squared left stuff, right? So sigma lives in the middle, and we do the square root of n minus 1, so 20 minus 1, times s squared, which is 3.2 squared, all over your chi-squared right number, so that's 30.144, right? They switch places. This guy, 20 minus 1 times 3.2 squared over 10.117. Now make sure that everything is going underneath of the square root. Everything. And I'm not getting, square root, open parentheses. I do 19 times 3.2 squared divided by 30.114. Or 144. Close parentheses. I don't know. 2.54?
yeah.
That's how many centimeters are in an inch. What?
How does that happen? I think that happened on a
I know. That's definitely happened before. Okay, then we change the bottom number and it is 10.117. And I got 4.39-ish. That's what we get for a confidence interval when we do that. Okay?
now we're gonna have to
So does that mean that he's equal to 3 or he's greater than 3?
equal.
Now we are in fact comparing to the 3 number, right? So he is in fact equal to 3 because 3 lives like somewhere here. Right there. Okay, good? So same results. Fail to reject. H not, claim false. Got it? You will get the same results regardless of which method you use. Yeah? Okay. How about that? Good? Happy? Okay. Let's go do some review stuff. Do you guys have your review with you? This is what he looks like. Chapter 8 review. Yeah? Chapter 8 review. Do you guys have a Skittles project after this?
We already did that.
No. We do Skittles for like 3 chapters. No, you don't. Okay.
So we get to do skills again?
No. Well, we will after chapter 9. I don't know. We'll see.
Well, apparently we're only gonna be here for 7 more days.
We only have 7 more days.
Yeah.
for chemistry,
So-
so.
Isn't that how that works in here too? Kind of.
Oh my lord. Okay, here we go. Number 1 and 2. Number 1, using the methods of this chapter, identify the distribution that should be used to test the claim about the given population, blah, blah, blah. The type of distribution. There are 3 types of distribution. There is the Z distribution, which is also called the normal distribution. There is the T distribution, or there is the chi-squared distribution. Right? Basically, it's like which chart are you using, right? Got it? We got to match them up. We got to figure out which ones go to which. Those are your options. You have the Z, the T, or the chi-squared.
When's our last day?
I don't know. It's the Tuesday.
Okay.
That Tuesday. You just have that morning, though, on Tuesday, because then you go and do your barbecue, and then you guys have graduation practice. I know. You'll be in here. A bunch, probably.
First and second.
Yeah. Because I think you check out a 5 through 8 on Monday. Haha. You guys are gone after Monday. The boys, because 5 through 8, right? Okay. All right. Okay. If you're doing a mean or an average, whatever, which distribution do you use? Or T. There's 2 options, C or T, and it just depends. Z if n is greater than 30, T if n is less than or equal to 30. Okay? If you're doing a proportion, which one?
Z.
Z. If you're doing a standard deviation, you are the chi-squared.
That's nice.
Got it? There you go. Good?
Great.
Okay, number 2. Determine whether the given claim involves a hypothesis test that is left-tailed, right-tailed, or two-tailed. If you're doing a test that says you're claiming that it's not equal to 0.5, do you do left tail, right tail, two tail? Two tail. Okay, if you're saying less than 98.6 and that's what your claim is, you are doing a left tail. By the way, if you do that, never mind. I'm not gonna go there. Okay, C.
Right.
Sigma is greater than, that's gonna be a right tail.
Can you
What
go
were you
there?
gonna say?
You should go there.
You should go.
It's the same answer. I was like, if that's the case, do all of those go in H0 or H1?
H1.
Yeah, those will. I figured one of them would go in H0, but it's not. Yeah, those ones will all be H1s, right? Because the top one's always equal to. Now you could end up claiming that it is equal to, and then your claim goes with the top with the H0.
Determine if it was left, right, or two-tailed. If they just gave us P's.
Sure.
You do too.
Yeah, you do two tail though, because if they don't say greater than or less than, you assume equal to, not equal to. Yeah. So, all right, number 3. Yeah, here we go. Number 3. In a Pew Research Center poll of internet users 18 to 29 years of age, what is 18 to 29? Nothing. We don't care about that. 53% said that they use Instagram. What's 53%? .53, which is what variable? P hat. It's from the sample. It's the sample proportion, which is called P hat. We want to use a significance level of 0.05, so I'm going to do a fish of 0.05 here. And to test the claim. Just look for those words. To test the claim that blah, 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 right? To test the claim that the majority, what does that mean? Yeah, greater than 50. So P here, we're going to do greater than 50% or greater than 0.5. That's the claim. And the top one is equal to. Are we getting better about this? We're doing okay? Okay, left tail, right tail, two tail. Right, what percent goes in it? All 5. We have an imaginary 5, and we have 90% in the middle. Okay, which one are we doing? Oh, use the p-value method. I'm gonna put that over here. P-value. P-value method. Okay. Using a sample size of 532. I'm on part B. Oh, identify the null and alternate hypothesis. We did that on A. B, N is 532. Find the value of the test statistic. Do you have the formula for that? Which row are we on the yellow sheet that you just filled in?
Second.
We're on number 2, right? We're on p-value, right? Okay, so we're on row 2, but the formula is p hat minus p over the square root of pq over n, right?
Yeah.
Okay, so then we just plop numbers in. P hat was 0.53
Minus 0.5.
minus 0.5 over the square root of 0.5 times 0.5 times, or over, 532. And we get that number, and that number is something, I don't know. I'm running out of room. 0.9162. Is that after you look it up on the chart or before?
This is gonna be after, right?
Oh, yeah.
Did you look it up on the chart already?
Yeah.
What number did you get before you looked it up on the chart? See, I know how this works. What?
Oh, 1.38?
1.38?
Yeah.
Blah, 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 blah.
That's right.
1.38. That's that number, right? This is technically your critical value, right? That's your critical value. But I don't want critical value. I want to then so that's part B. That's the test statistic. That's your critical value, right? 1.38. But in part C, it says use the p-value method. So I want to take my z, which is 1.38, and I want to convert him to a p-value. How do I do that?
0.91.
You look them up in the chart. So like 1.3 and then go over to 0.08, right? 1.38. And you go down and he is what? 0.9,
162.
0.9162, okay?
I just checked it, so.
All right, 0.9162 or 91.62%. We should have labeled our bell curve, but that's fine. 0% goes here, 100% goes here. This cutoff mark, which is imaginary, is 5% here, and this is 95%. Do you see how we label those? Where does 91.62% live?
And the equal to.
In the equal to. He lives over here, right? He's not quite 95%. It's like I'm filling across. 91% is falls short of the 95 cutoff. So we circle which one?
Top one.
The top one. He is equal to, he is not greater than, right? So what should we conclude about the original claim? Fail to reject H naught, and claim is?
False.
False. You betcha. Beautiful. Like if I ask you to say like, what does that mean in like layman's terms according to this?
Layman's terms.
Layman's
Is
terms?
that who this is?
No. Layman like means
Layman is-
layman it means like average people terms,
Bull crap.
Oh,
right? If I ask you what that means, like
Gang.
what does this mean? Like
equal to majority.
that it's okay?
No, wait.
Majority would be greater than. So majority what?
I need more paper.
No.
Majority are.
Don't use Instagram. Right?
Yep.
According to this. That's what this means, right? Like if I ask you what that actually means, right?
Don't do that.
Blah, 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 blah. All right, number 4. True or false? In hypothesis testing is never valid to form a conclusion supporting the null hypothesis. Can we say that the hypothesis is true?
Yeah.
Yes.
Kind of like on this last one. When we circled the hypothesis, what did we write for the hypothesis? Fail to reject, right? That doesn't mean it's 100% true. It's just according to my data, I don't have enough to prove it false at this point, right? Like my data supports it right now, but maybe the next set of data won't. So that's what they're asking in question number 4. Is it is never valid to form a conclusion supporting the null hypothesis. That should be true, that it is never, that you never 100% support the null hypothesis. Does that make sense? We only fail to reject the null hypothesis. There's a difference. Do we understand the difference?
You never what?
Well,
You never 100% support the null hypothesis, which is what they're saying here. You never support the null hypothesis 100%, right?
well, that's why I was confused by the word.
Okay, you only fail to reject it, right?
Supporting.
Okay?
It didn't give me a very good
So it is, and that's kind of weird. It is true that you never support it 100%. All right. Number 5, true or false? The conclusion, fail to reject the null hypothesis, has the same meaning as accepting the null hypothesis. That's kind of the same, along the same lines. That is false. Fail to reject just means I don't have enough data to say that it's wrong at this point, but the next set of data might prove it false, right? Okay, so false. Okay, number 6. What?
Did you finish the?
Yes. I recorded it all. I'm recording right now. In a test of the claim that the standard deviation is 15 for IQ scores, we find that the right critical value, chi-squared right, was 40.646. Does that mean that the left chi-squared value is negative 40.646?
No,
How's come?
because that's not how that works.
Chi-squared doesn't go positive, negative like Z and T do, right? So no. Chi-squared values are only positive, right? And they're not even the same number. Like one of them is 10 and the other one is 40 or whatever, you know, like that's how they work, okay? Chi-squared values are only positive. That's how that goes. Yes, sir.
Are these questions on the test? Like how it's
I don't remember. Ask me that tomorrow and I'll look. Like there might be questions that are like this, like I think I more so do like, tell me what the chi-squared values are if this is true. So you don't have to go through the whole hypothesis test. I just want to make sure you can use the chart correctly. Does that make sense? So it's not like it's giving you free points without having to do the whole hypothesis test. Yes, ma'am.
Are we testing on Friday?
Are we testing on Friday? Yes, probably.
Okay.
We're gone on Friday.
Oh yeah. Yeah.
I can probably take mine tomorrow if you haven't done.
I'll
Sure.
just take it.
I have 'em.
I don't know when. I don't know when. I don't know
Yeah.
when I'm gonna make up on my work.
Yeah.
Hey, Carter,
Yeah.
my water bottle, there's-
And then Monday, if people aren't done, I don't think should be a long test. But if people aren't done testing, then Monday they can finish before everybody's gone, like on Tuesday and
I'll just
Wednesday
make up
and
all my work by
blah,
Tuesday.
blah, 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 all the things.
That's whenever.
But you're gonna be here Wednesday, Thursday, Friday, so that'll be helpful. So yeah,
I don't know. Am I gonna be here all
I
next
need
week?
to quit blowing.
I don't know.
I don't think I will.
These out to the-
Are you track?
No.
No.
But I
Okay,
bet
so
you
then you'll be here for
something's
yeah, something will be happening. I'm sure. This is cute.
What is
You here?
cute? This is cute.
Okay. All right. So we really only have like 6 problems left, right? Those guys? Yeah. Okay. Here is the deal. Label these real quick. Because we've already, on number 3, we've done a p-value for proportion, right? That was row 2. Row number 2. Got it? P-value for proportion. Row 2. Got it?
Actually, I am here all next week.
We have 2 problems for proportion. I want you to do the top one, the Mickey D's. That's going to be a critical value, so that will be row 1. Okay, for proportion. Then I want this confidence interval style, which is row 3. Okay? Yeah. Critical value, row 1. Confidence interval, row 3, because we've already done a p-value up above, right? Okay? That's what proportion will look like, just because I want you to practice those. Okay?
What does row 1 mean?
On the yellow sheet. Yep. Speed dating for mean. Do this critical value style, right? And that is row number 4. Okay, critical value. The next one, got a minute, is confidence interval style. And that is row 5. Yeah? We see how this works? Okay? The last 2, standard deviation, we'll do critical value here and confidence interval here, which would be rows 6 and 7. Does that make any sense?
Yeah.
Row number 6, row number 7. Okay, how about that? All right, do we want to tomorrow? Like, we only have 6 problems left. Do you want to tomorrow, me just give you a day to work on those 6 and you can try them on your own and do all the things? I think you can handle it, right? If I just give you a day to work and then you can ask me questions and I'll go around. Maybe I'll do them on my own and you can check your answer, right? That work? Is that helpful? Okay. I'll try to do that before sixth period, and Reese, if you want to check your answers with mine or whatever before you take the test, that'd be fine. Okay? Good, good? Yes? Okay, so workday tomorrow, test on Friday, yeah? All right, there we go. Okay, goodbye, Josie and Aiden, even though Josie, you're here.
Me.